But
problem, but sir, everyone is requesting, sir, in the group.
no, that's okay. I have no problem. I have no problem. So, or maybe there could be some kind of problem. Let's say something is given to you. Let's say you are picking some points from a square. Let's say the square is given to you, meaning let's say this is AB. Okay, something is given to you, AB. Let's say it is a square. Okay, it could be rectangle as well. Some AB to CD. Now the length could be like this. Let's say this length is let's say something L1, and this length is something L2. Something is given to you, and then suppose the problem is like you have to pick some points, okay, and you can pick let's say the points uniformly from this region. Then the question could be, okay, what is the probability that okay this will be picked from some particular sub area of this. Let's say some point is given to you, that let's say this point, these 2 points are given to you, something let's say x1 x2, and here it is y1 y1 y2. So you know this region. So then what is the probability that the points will be picked from this particular region? So then what you have to do is basically this is the area, and this is a region, let's say A, and this is the entire region. So this is sample space S. And sample, you can define the probability of A. Picking A is that like the how much area does this contain divided by the entire area. Okay, let's say the area is let's say mod S. So then this is the probability. Then that's it. So this kind of problems could be there. So many, or let's say something is written, let's say X is following some kind of distribution, which is not, let's say it is normal 0, 1, and you'll be asked to, let's say, what is the probability that let's say X plus, okay, some X by 5. Okay, this is simple, but let's say 5 by 7. Okay, if it is bigger equal to 6 or not. I mean, what is the probability that this is equal to? Or some function is given to you. Let's say, yeah, some function is given to you, some fx, and then whether it is less equal to or bigger equal to something is given to you. Let's say this is there, and you'll be asked to find what is this. This can be one problem. Yeah, so basically the thing is there will be so either this will be a function. This kind of problems could be there. This is one kind of problem, like you know that how x is, the random variable x is distributed, then you will be asked to find what is the probability of some function of x when it is lying between, let's say, a less equal to b, a b less equal to fx less equal to b. What is that? This is one kind of a question. So what you have to do, you have to write what is fx, what is that. For example, here, suppose it is x plus 5 by 7 or whatever it is given. So then it means x is so probability of, if you do it, probability of x bigger equal to 6 minus 5 by 7. So then you use the PDF definition of this and then find it out. This is one kind of a problem, and another kind of a problem is something about some phenomena is given in the problem, and there is a random variable, and the distribution is also given. Or sometimes probably you have to find what is. I mean, there are enough information. Using that, you have to find the distribution. Let's say the mean is given, yeah, then probably you have to calculate the variance. Something is given, something is not given, and using the formula, let's say mean is given. You know the mean, but you do not know the variance. So you know what is this? Some parameter is given to you, which is like mean of the distribution. PDF is given to you, or mean of the random variable is given to you, and then probably you have to compute variance, and then probably suppose it is given, let x is normal, some a n, mu is given to you, but sigma square is not given to you, but you know the form of fx. Okay, or let's say fx is beta. There are two parameters, something like that. I mean, some distribution is given to you, and enough information will be supplied to you to find all the values of the parameters. And then again, the question will be, okay, the probability of something, let's say x, something, x is bigger equal to or less equal to 5. Okay, what is that? So this kind of questions will be there. I mean, what you have to look at it basically is like you should have a cheat sheet, meaning you have a sheet where all the PDFs should be written. I mean, so that you don't have to go through the lecture and find out what is the PDF. Okay, you can easily find out what is the PDF and see what information given in the problem, and according to you have to use it and solve the problem. Yeah, sometimes, so I always say the trick is here, because this is an online exam, that's the problem. So you do not have enough time to solve a problem. I mean, enough time means you do not have, you cannot spend much time to solve one particular problem. So meaning, so what you have to do to optimally use the time is basically you have to understand the question. You should not misunderstand the question. This is the first thing. So you have to be a little patient. Okay, whenever you are reading the question paper, so this is the important thing. Okay, so keep patient, be quiet, and read. Understand the question. This is main problem. Understand the question. What does it? What is the information which is given to you and what it is asking? Okay, understanding is the main part. So you have to understand what is. If you misunderstand the question, okay, then there will be a problem, right? So so keep quiet and yeah, keep patient and be quiet and read the question carefully, and then whatever the information given to you. So this will be very simple. Everything you know, all the PDFs you know, and basically in a probability course, what can people ask? Only people can ask about probability of an event. Event will be given to you. Okay, and there is a random variable. So you need to know what is the PDF. Then only you can find the probability of the event. And to understand what is the PDF, either enough information will be given to you. So this is one thing. Or let's say there could be some functions of some mean and variance. So this kind of question also can occur. Let's say let's say the variance of x to the power 5 is known. Okay, then you have to find something. Okay, so there is a function whose variance you know, or let's say suppose you know some moments. Let's say x to the power 5 something is known, or maybe a general form is given. All the moments are given to you, and then we asked to find, okay, what is the variance or some function of the variance, something like that, or to some ratio of variance expectation, something like that. I mean, you will be supplied with enough information about the random variable, and then there will be something which you have to find out. So like I said here, let's say the moments. So all the moments about the mean are given to you, and then you'll be asked to find, let's say, whether the variance, what is the variance of x to the power 5. So this is a new function. So you know the definition of variance. So that means you have to find the corresponding. So this is a new random variable. Let's say this is y. So what is variance of y? So you know the formula for the variance of y. This is y square minus e of y whole square. So basically, you first need to find out what is the mean, and then you have to find out the expected or the mean of y square. So that's it. So yeah, so this kind of problems would be there. So you should always, what you need to do is basically you should have all the list of all the PDFs. Okay, list of all the PDFs ready in hand. Okay, what are the PDFs, so that you don't have to look, like if suppose something is exponent, something is beta, something is varying as gamma. Okay, so don't have to find out like what is the corresponding distribution. You know everything, all the parameters are given to you. Then you have to just use the formula to calculate probability of that event. So this will not be, okay, so I must say also that if you practice a lot, like because this is nothing but you have to evaluate some sum, okay, sum of something, or you have to perform an you have to evaluate an integration. Okay, let's say it to be. So this is the trick how to perform. I think you should know how to evaluate an integration. So you know how to calculate this value or this value, and that is enough. Yeah, and yeah, some people also do. I mean, that should not be recommended, but some people also use some software to calculate this. But the problem with software is that, okay, software. I mean, whenever you are using some kind of a software, it always there's a problem of storing. Storing means, suppose there is some kind of a root 2. Okay, now the question is, root 2 cannot be saved in any computer. I mean, the precise value of root 2, the exact value of root 2. So it will, of course, it will assign some value for root 2, maybe up to 3 decimal digits or 4 decimal or 5 decimal digits. And then whatever the question, the answer you get, that will be approximate to some value. And let's say this is also root 3. Okay, so there is a lot of chance of error when you are not doing exact computation. If you are using finite arithmetic, that means you are, or let's say fixed point arithmetic, like any computer system uses fixed point arithmetic, let's say. So then the problem will be your answer, whatever you get from the computer, need not be quite close to the exact. Exact means what? Let's say you take this root 2 value up to 5 decimal digits and root 3 value up to 5 decimal digits. But your computer system, let's say it assumes only up to 2 decimal digits, and there will be a problem with the precision. Okay, and if there is a lot of arithmetic involved, let's say you have to divide you have to product, or you have to make a multiplication, then errors will be accumulated. And finally, whatever you will get, that will not be, that will be far from the exact value. And then that would give you some kind of a problem. Okay, whenever, but so better is use a calculator, or maybe you can use any computer system, but whenever you take the root 2 value, so you take up to, let's say, 5 decimal digits, because most of the problems will be up to 3 decimal digits. You have to write the correct answer up to 3 decimal digits. So it is better to take up to 5 decimal digits for this kind of values like root 2 and root 3, and whatever the arithmetic you are using, let's say multiplication, division, whatever it is. So you do, and then get the value up to 5 decimal digits and approximate it to round it off up to 3 decimal digits, and then write the answer. Okay, so this could be sometimes a problem. So it is always better. So these kind of problems are not there in an offline exam, because we can see what you have written, but here we do not know what you have written. Only you have to give the valid answer. The final answer has to be correct. Okay, so yeah, so and we do not know how you got the answer. In a typical offline exam, we know how you got the answer, but here we don't know how did you get the answer. So in that case, okay, it is always better to take many, let's say 5 decimal values, and then decimal digits, and then you perform the computation. Yeah, this kind of problems would be there. So there will be a set or something is to be given PDF, and you'll be asked to find probability of some event. Okay, and or some function of some random variable, something will be asked. So you'll be supplied with enough information to understand like what is the distribution, or sometimes the distribution, most of the cases distribution will be also known to you. Like there is a parameter which is distributed as, or there is a random variable which is distributed as, that's a gamma or beta, and then you'll be asked to find the probability. So only thing is you have to carefully use the formula, because in the formula there is, for example, in beta formula, or there is something to the power something, e to the power something. Okay, there is a lot of things. Okay, so there are things which can be a matter of concern or confusion, let's say. So you should have a cheat sheet ready with all the PDFs. You know all the PDFs, and then you have to use it to solve your problem. You should not lose time to find out the formula of the PDF. Okay, so yeah, that is how the questions are given. So that you have you know all that PDFs, and then you apply it and then solve the problem. Calculate the value of some probability of some events. Yeah, these are the problems basically. And the kind of problems which I discussed during the course, during the classes, those kind of problems only will be there. They are the typical problems. Okay, like this, or maybe today whatever I discussed, this kind of problems will be there. Nothing much. So it is not like what you don't know. The question is about what you know or what you should know, let's say. So this is not an exam to check how much you don't know. It is not like that. People do not know many things. I also do not know many things. Everybody, okay, does not know everything, right? So that is okay. But the thing is, whatever is discussed in the class, that minimal information like the PDFs, okay? And if you know the PDF, then how to calculate these values. You will see later also, whatever we are doing here right now in this course for the time being, this will not be very much applicable when you are solving a real world problem, because in a real world problem, you even do not know what is the PDF. Even if you have a guess about which we will discuss during the statistics part. And if I cannot do the statistics part, you will not get a flavor of what happens in real world. What is the use of all this concept in the real world. Here in an idealistic world, you know everything, how a random variable is distributed, you know values of the parameters, and then you just calculate the probabilities. So this is a very ideal situation, but this is not real world. In a real world, you have a data and you do not know what is the distribution of the data. Even if you make a guess about the distribution, you do not. But let's say looking at the shape of the PDF or something you have drawn, and from there you have a guess. Let's say it is normal, okay, or something, and then you do not know what are the value of the parameters, like for which it is giving you this kind of distribution. Then the question will be, okay, how to estimate those parameters so that this given data can be explained, okay, as a distribution, That's a normal. But then question is, what is the value of mu and what is the value of sigma square? Okay, so in the real world, this is not given to you, that how it is distributed. You have to find it. And these are the specific distributions. What? This is the standard distributions which you know. So whenever you look at a data, okay, so let's say the shape of the data, you draw the PDF, which is very difficult, by the way, as I said before also. So for example, what could be a difference? Like if we have a normal, you have a very sharp decline. So decline, very sharp. This decline is very, very sharp, let's say. But in kind of, let's say the gamma, there could be some values of the parameter, let's alpha, beta, where let's say it is like this, but this is heavy tail, this is like this. Okay, then you can make a guess that this is not normal, but it could be a gamma. But you do not know what are the values, because for some values of this, it also could like this. So then you are in confusion, like whether it is normal or not normal. So yeah, sometimes you can make a guess looking at the PDF, but you do not know what are the parameters. Then the question will be how to find the parameters. So real life is challenging. Ideal here, what we are doing in this course till now is not real. This is ad hoc. I mean, just to know that if you know PDF, if you know some values, then how to calculate some probability of some events. So we are assuming a lot of things here. And the assumption is basically, you know that there is a random variable X and you know how it is distributed. So you know what is the PDF. Okay, and accordingly you are solving some problems. Yeah, so yeah, this is it. I mean, yeah. If you have any other questions, you can ask any specific question. This will be a similar kind of exam which you have, I mean, you have already appeared in the first class. It will be similar to the first class test. It will not be very different from first class test. Only thing here is that, yeah, you have to remember the PDFs. That is important. I mean, you don't have to remember, but you should have a ready-made sheet, paper sheet, where you can see like these are the PDFs, and then accordingly you have to use the formulas and the values, calculate the probabilities. And not only that, you don't have to also see the table. All the required values, let's say some phi means I'm talking about standard normal. So phi of something is given to you already. Let's say 1.95. Okay, so this value is already known to you because it is given in the question paper itself, either in the instruction or in the problem itself. So read the instruction carefully. Okay, in the instruction, all the values are given to you, whatever you need to know to solve a particular problem. So you don't have to spend time to look at a statistical table. I mean, table for PDFs or for CDFs for different values for a corresponding distribution function. So you don't have to look at the statistical table. It is already given in the question paper. So yeah. So then from there also you can make a guess what kind of values, whether you are doing something wrong or not, because those are the required values only you have to use. Yeah. So okay, if there are no more questions. So let me just recall what we have started last week discussing. And a pair of random variable, or which we called bivariate distribution. Bivariate, there are two variables. So the bivariate case. Earlier we are doing univariate, meaning there are only one random variable. Here there is a pair of random variable, x and y. And then we said what is, if they are discrete, if this is discrete, this is, so for the discrete case we talked about fxy, which is probability of x equal to x and y equal to y for any small x, small y. So then this is basically a function of a two-parameter function, a two-variable function. Okay, earlier for the univariate case, when we had only one random variable, this is a single parameter. Okay, like the small x is a single parameter. Here we have two parameters, and this is explained as this is suppose it is event A, So there is a random variable which takes the value small x. There is a random variable capital Y which assumes the value small y. This is B. Then this is the event A intersection B. Okay, this is how the PDF is defined. And for the case of continuous, we said okay, as we discussed for the case of one univariate or one random variable, we said okay, suppose we have a function area under which is 1. Then we can say, okay, what is the probability? So this is the values of x here. This is the value of x here. For the case of one parameter or one random variable, single random variable or univariate case. Then if we have some region here, let's say A, what is the probability of A? Then we said, okay, the area in this region. So this is the probability. So if I know how this curve, if I know this function, then that there is some random variable x, so distribution or PDF is of x, and then if I ask to find out what is the, let's say, probability of x bigger or equal to 3, suppose this is this region A, okay, a bigger or equal to 3 means, okay, I mean, let me write probability of A less equal to x less equal to b, so this is A, this is b, then this is the area. So basically this is in the form integration A to b fx dx. The same thing is here. Instead of one parameter function, we have two parameter function because there are two values, x and y, both are varying, like height and weight. This is always to remember that there is kind of some fxy, which is now a surface, not a curve, okay? And the region is somewhere here. This is the xy plane, okay? Some region is there. Let's say this is the region. So let's say this is the region. So then there is a corresponding surface above this. And then what is the probability is basically, let's say this is the surface. And then let's say this is the surface. Okay. This is the surface, let's say. And then what you have to do is you have to calculate the volume under this. Okay. So if this xy plane here is the region A, then probability of this A is nothing but integration. That will be double integration, or we can write just xy belongs to A, fxy dx dy. So underlying principle is same. Here, instead of area, because there was a curve, so area under the curve, here the volume under the surface. Yeah, so basically this is what we discussed. And then we said, okay, suppose if I know fxy, okay, fxy is equal to some function. Let's say x square plus y square, and xy is something, okay, xy is something. So it is in some region, let's say A, and 0 otherwise. So this is how it is given. Then the question is, okay, from here, can we compute fx? Fx means, or I can write fxx. That means what is the probability of x equal to small x? Okay, so here it was joint distribution, joint PDF. So we use the word joint PDF. Here we are calling it marginal PDF. Marginal PDF corresponding to the x, random variable x. Then for joint random variable means the bivariate case here, there is a pair of random variable x and y. Okay, and this is an ordered tuple, meaning the first random variable is capital X, the second random variable is capital Y. And then if it is continuous, we said what it is. Okay, and if it is discrete, then also we said what it is. So we talked about what is called the marginal distribution from the joint distribution. So if I know joint PDF, then we can calculate marginal PDF or the individual PDF of the random variables. And we solve some problems also, like how to for different kinds of examples. If fxy is given to you, the joint PDF, then how to compute the marginal PDF. Yeah, so this is this much thing, I think, what we discussed. Now today what we'll do is, we also talked about what is the CDF and these things. Okay, all the basics we have discussed. Okay, now today we'll start talking about what is called the conditional distribution. Okay, this is where we'll start today. This is called conditional distribution. Conditional distribution. Okay, what we have here is just recall. I mean, when an x suppose x and y. This is the motivation for this conditional distribution. Suppose x and y are discrete. Discrete random variables. Okay, then what do you know? We know the PMF or the joint PDF. The joint PMF. This is what? This is probability of x equal to small x and y capital Y is equal to small y. This is what you know. Okay, so you said if we write this as A, this as B, then we can say okay, this is probability of A and B, right? A and B. Now, if you recall our definition of this thing, our definition of conditional probability, okay, then we can remember that A given B, probability of A given B for any two events is nothing but probability of A and B divided by probability of B when it is non-zero. So denominator part has to be non-zero. This is the definition of conditional probability. Now, if we use this here, what is happening? So then we can say, what is this probability of A, meaning probability of this event, x equal to x, this event, given y is equal to y, small y, this is B, and this should be equal to probability of A intersection B, so that means probability of x equal to x and y is equal to capital Y is equal to small y divided by probability of capital Y is equal to small y. This is it. So this numerator part is nothing but f of xy. The denominator part, it is nothing but the marginal PDF of y. Okay. So if we write this now, this function as some function, okay, which is let's say g x given y. If we write this as this, what is the meaning of this function? Same meaning. This is the probability of x, capital X equal to small x, given capital Y is equal to small y. Then we have this formula. And this is exactly the definition of what is called the conditional probability. So let me define formally what is the conditional probability, definition of conditional probability for a pair of random variables. Okay. So the conditional probability, the conditional probability density function, probability density function, let's say g of x given, okay, y is equal to some small value y, okay, is defined as g of x given y, which is f of xy divided by fy y when fy is positive. I'll explain what is the meaning of this. And if you do the reverse, the probability conditional probability density function. Okay. Now, when x is given to you, okay, then so you have to say what is the conditional probability function of y given capital X equal to some value small x. So similarly, the conditional probability density Pdf, let's say h, this function of y given x equal to small x, okay, is what? It's h, okay, y given x is equal to f of xy divided by f1 of fx of x when fx is positive. What it means is basically, okay, so suppose you have discrete case, everything is a table, okay, this is let's say height, this is height h, and this is weight, height by weight, okay, or anything. So this is weight w. So you have some height, weight, then you know what is the probability value. So suppose I collected data, okay, where this information is given. Like I know what is the probability. So let's say this is W1, W2, dot, 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 some Wm, or let's say both are, okay, M, and here it is H1, okay, HE, okay, or just HT, because H I am using here. So HT1, HT2, dot, 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 some HTN, let's say. So I know what is the probability. I know these values. F of W1, HT1 means, let's say the heights are starting from 3 feet, okay, to 3.5, 4, 4.5, and so on up to something. So 10, up to let's say 10 feet, okay, from 3 feet to 10 feet. And weight is, let's say, from 50 or 40 kilos, 40 kg to something, 45 and so on, or maybe, yeah, something like that. It is given up to same number of points in an M, both are M. So I know what is the probability that when height is 3 feet and weight is 40 feet. I know when the height is, probability that height is 3.5 feet and the weight is, let's say, 45 kg. I know all these discrete values. Okay, now what I'm asking is, suppose I fix the height. Let's say my height is something here, which is, let's say, 7 feet. My height is same, so this value is given to me. This could be y, this random variable could be y, and this random variable could be x. So I know there's joint PDF, and I know that y is equal to 7 feet. Let's say this is the unit. Then I'm asking, what is, let's say, the probability, let's say, what is the probability that the weight is, let's say, some 50 kg? This is my question. So when I know the value of y, okay, then what is the value of x? And if you make this value x instead of 50 kg, let's say I make it a variable, then the question is, if 7 feet is given to me, then what is the value? What is the value of x equal to capital X equal to small x for any x? So x could be 40 kilo, 40 kg, 50 kg, 50.55 kg, 60 kg, and so on. So for any value of x, when x is lying from, so this is the question. So this is equal to when let's say x is varying from 40 to up to, let's say, 70 or 80, whatever, 80. So then this is x is the parameter. So this answer should be a function of x. Otherwise, if I pick a particular value of x, then I have to find out what is that answer. So what is the probability that, let's say, the weight is 30 when the weight is 50 when the height is 7 feet. Okay, so this is kind of a scenario right now here. So it is just height and weight, but if you have two parameters measuring something, okay, suppose you are a company which is producing something, okay, suppose it is producing some kind of a toy, okay, and toy had different kind of parameters. So let's say it is producing some kind of Legos, okay, Legos. So there are different kinds of Legos, and then you have to measure the height and the weights, okay, corresponding to these Legos. But since it is produced by a machine, okay, the area, or the, let's say, the shape did not be always fixed, okay, due to some error in the machine or the measuring device, whatever you are measuring with after, let's say, it is produced, okay, then, but you want to make it precise, like all the Legos would have the same area, let's say, or the same, if it is a three-dimensional Lego, let's say, I mean, you can consider it as three-dimensional because it is like a brick. So you can consider that it has three parameters: height, I mean, length, breadth, and this height. Okay, there are three parameters. Then the question is, what is, suppose if I ask you, what is the probability that, so let us consider it is two-dimensional, not like, so let us consider this is flat. So there are two variables only. One is this x and another is this y. Okay, so then what we can say is, what is the probability that suppose this y, this value is given to be something like 2.5 centimeter, and what is the value that x is something. So then you have a whole lot of samples. Okay, we'll talk about what is a sample, but let's say the company has produced a lot of let's say Legos. Okay, but you cannot measure all the Legos. Okay, that let's say there are 10 lakh Legos. Okay, this kind of small chips kind of thing it has produced. So you cannot measure everything. Okay, but you can pick a sample. Let's say you can pick 100 of them, and then you measure everything 100, and then suppose you are able to find this distribution, that f of xy. So after measuring everything, all these 100 Legos, you have a notion of what is the probability of, let's say, the value of y when the value of x is this. So you know all these precise values, let's say. Then the question will be, okay, when this is 7 or it is something, some value on the y-axis, then what is the value of the x? Same thing you can reverse. So let's say you know the value of y, then, x, then what is the value of y? You can do the same thing. And this is the formula to do it. So this is, so here you can consider, let's say here, so you are actually, we'll talk about that later also. We'll just, right now, we'll just define this formula and solve some problem, but it will later on, I'll discuss this, I'll explain this as random variable. What is the random variable here? X given y. So this is the random variable. So what I'm saying here is, when I say x equal to small x given capital y equal to y, I can write this as a new random variable, which is denoted with, let's say this one. Or I can just say x given y. This is my random variable. So I know the value of x when y takes some value, this one. I do not know, let's say, the paired xy. Okay, that I do not know the joint distribution, but I know only this one. Okay, so I know only these cases for certain instance, but I do not. So this is a big table. Let's say for certain columns I know the value, but for other columns I do not know the value. Okay, so this entire thing can be explained as a new random variable. Okay, we'll treat that as a random variable later on, and we'll see how to calculate the mean and variance of these random variables. Okay, because this is now single random variable given some other value of some other random variable. Okay, so this is what is called conditional random variable or conditional distribution. But here, for the time being, what I'm saying here is, if I know the marginal distribution of y and the joint PDF, then I can compute this value, which is called the conditional PDF, conditional probability distribution. When y is known to, y is given supplied to me, and I can find out what is gx, because this is a function of x, because x is varying here. If you want to pick some particular value of small x, then you can put it here. You know this, suppose you know this, because suppose you know joint PDF, then you know marginal PDF. So I can compute these values, and then I can find this value. Same thing is here. Once capital X assumes some values, so let's small x, I know the joint PDF here, then from there I can find a marginal, and then I can find probability of this. So let us solve some problem and see what is happening here. Okay, so this is called conditional PDF. Okay, now this is, let's say, an example, some problem. Suppose the PDF is like this, f of xy, which let's say 1 by something 21 x plus y, let's say. Okay, and let's say these values are given when x equal to 1 to 3 and y is equal to, let's say, 1 2 and 0 otherwise. So this is the kind of the PDF, joint PDF. Then suppose the question is what is this? What is gxy? Gx given 2. So the small y is given to me. So that means what I'm asking is, what is the probability that x, capital L, takes this value small x? X could be small x could be anything, but capital Y, this value is 2. You can also write what is probability of x given 2, or given y is equal to 2, or you can write probability of x given 2. So here I should not write like this. So instead of that, I write this kind of notation, x equal to y. Okay, so how to solve this problem? Any idea? Is anyone there listening to me?
Yes, sir.
Yeah, so how to solve this problem?
Sir, is it 2x by 21?
I don't know. Let me just check. So this is small x equal to this given 2. So y is equal to 2. And this should be according to the formula. This is f of xy, right? y is equal to 2 here. This is already given to me. Divided by f of y at 2. So from this joint, I have to first, so I know this value, right? Can anyone tell me what is this value? This function is given to you.
2x by 21.
Okay, and what is this value? So this is the marginal PDF. How do I find the value of this marginal PDF? So Fy, let's say this 2. This will be called what? If this is any y, then what do you do? This is sum over all xy over all x. Okay, but this small y is equal to 2 here. So this will be then this marginal distribution is all over x, f of x2. So x here is 0 except 1, 2, 3. Okay, so then this will be nothing but sum over, or I can just write f of 1, 2 plus f of 2, 2 plus f of 3, 2. So I need to plug these values here because I know these values from here. Then I know the denominator, and similarly I know the numerator, and that's it. So then I can find it the values. Okay, I know this one. This one will be what? I have to put just y equal to 2 here. Okay, so how did I define x comma y or whatever? Yeah, so this is product or addition, whatever it is. Some function is given to you. So I just put y equal to 2, then I'll get, so 1 by 21 times x plus 2. Okay, so yeah, this is how we can find out for the case of discrete. Any question regarding this problem? This is very simple. Just have to use the formula. When joint distribution is given to you, you have to use the joint distribution to calculate the marginal one. Then you know this. That's it. Okay, let me solve one more problem. Let's say this time, let's say I have a continuous random variable. Let's say fxy. This is equal to, let's say, 12x when 0 less than y less than 2x less than 1 and 0 otherwise. So here the region is 0 less than 2x less than 1. So can anybody tell me what does the region look like? So y is equal to 2x, you can find it out. Yeah. The question here is, what is the probability of, let's say, y when x equal to some value small x? So small x could be anything anyway. What is this equal to what? So what is the region here? Y is equal to, y is less than 2x. So y is varying from, let's say this is x, this is y. I mean, you need not draw it, but let me draw it. I mean, without drawing it, you can also solve the problem. Y is lying between 0 to 1, x is also lying between 0 to 1. So this is, let's say, 1 here up to this one, and this is 1 here. Then y is equal to 2x. What is that? Y equal to 2x. Then you have to say what is y is less than 2x. Okay. So straight line from what to where? So this is y equal to x, right? This one is y equal to x. So okay, so you can find out what is y equal to 2x, then you have to take one side of that. So because y is less than 2x. So you know that. Then you have to find out this one. Also use the formula y given x. So this is what? This is f of xy, which I already know. Get by fx here. How to find the marginal here? This one. What is the formula for the marginal?
Summation.
For the case here it is continuous, so I have to take integration minus to infinity fxy dx or dy.
dy.
Which one? Dy. Yes, that's it. So you know that this is 12 times x. You have to perform an integration, you'll get the value. although it is minus to infinity, but it is, so what is the domain here when it is non-zero? When y 0 is less than y less than 2x less than 1. So what is the value here? What is the lower bound here? What is this value? What is this value? Upper bound. Y is varying
0 to 2x.
0 to 2x. Yes, 0 to 2x. That's it. 0 to 2x, 12x dy. You know the value, and you already know fxy, so you can compute this one. Done. So yeah, this kind of problems. Okay. Now, so this is the formula. You can compute conditional probability. But why did I discuss this? Because now, let's say, as in this kind of a situation, that you have a table. Let's say, for the case of discrete, just I said, this is, let's say, height, and this is, let's say, width. Okay. Now, question is, if I fix some value here, let's say this is 7 feet, height is 7 feet. Okay. Whether weight, the distribution of the weight, does it depend on the height? That's the question. Or if I fix this value, let's say for height, for weight, now I want to compute the distribution of the height, given the weight is that. So the question is, does it depend on the choice of the height or not? So if I fix any value small y here, so then whether this depends on this y or independent of this y? That's the question. So this conditional probability, when whatever we have considered here, the same old problem what we discussed for a single variable, whether this is independent of this given x value or not. That's the question. If it is not, then we would say that x and y, the random variables x and y, capital X and capital Y, they are independent. Okay. So we define two functions, gxy or gx given y, and h y given x. Okay, we know this. We know this. This is what fxy divided by fy y, and this is f of xy divided by f of x. So the question here is, does it depend on y or does it depend on x? Here is the definition. If it does not depend on y, this does not depend on y, then we will say x and y are independent. Or here, if h does not depend on small x, then we will say also it is independent. So question is, what is the definition of independent random variable and dependent random variable? Now see here, if it is independent of y, so this is a function of x. So it automatically means, so it is some function, gx, let's say. So then this is equivalent to saying f of xy can be written as some gx times some function here fy of y, and this is also independent of small x. So this function fxy, this can be factored into a product of two functions. One is a function of small x, another one is a function of y. Same thing is here. So if it is independent, this h of y given x, if it is independent of small x, then this is some function h of small y, and then this is nothing but f of xy divided by fx of x. So here also it means f of xy can be factored into a product hy times fx of x. And this is actually the definition of independent random variable. When this function, okay, this joint distribution can be factored into two functions. Here, this is a marginal distribution, and this will be a marginal distribution corresponding to y. This is a marginal distribution corresponding to x. So this is, let me just write the definition itself. Let x and y, xy be two random variables with with joint PDF f of x, y, then x and y are said to be independent, or sometimes it is called stochastically independent or probabilistically independent, are called stochastically independent, if f of xy is equal to f of x, f of y. So if the joint is the product of marginals, then the corresponding random variables are called. So this has to be true for all xy, okay? For all xy in the range space of x times range space of y. So if the joint PDF is the product of marginal PDFs, then we would say that x and y are independent. Okay. So let us see some problem. Suppose f of xy is equal to something. So let's say this is equal to e to the power minus x plus y when 0 less than x, y less than infinity, and 0 elsewhere. Otherwise, question is whether are x, y independent. Okay, in order to check independent, whether they are independent or not, we have to first find out the marginals. The marginal is what? 0 to infinity, because this is why it is non-zero. fxy, it is the power minus of x plus y times dy. So what is this? Can anyone tell me? Can anybody perform this integration and tell me what is this? Marginal correspond to capital X.
E raised to power minus x.
E to the power minus x. Wow. Similarly, if you do find the marginal corresponding to y, what do you get? This is from 0 to infinity, power minus x plus y dx. Of course, it is symmetric, so this has to be e to the power minus y. So what is happening here? You see, in fact, this function, it can be written as product of two functions, which you did not see when the problem was given to us. This is an observation, that because e to the power minus of x plus y, this is not even minus x times e to the power minus y. So when this PDF is a product of, then the question is, when the PDF can be factored as a product of two functions, one is a function of x, another is a parameter of y. Okay, then the PDF, joint PDF, is always independent. Okay, so this is a criteria to check if this cannot. For example, let me tell you, give you an example. Let's say fxy is something like x plus y. Okay, somewhere let's say it is 0 less than xy less than 1, and 0 otherwise. 0 otherwise. Now, is it linearly x and y? Sorry, are they dependent or independent? Means the question is, you can find out the marginal PDFs and you can check whether this can be x plus y can be written as a product of a function of x and a function of y. But looking at this function, can x plus y be written as a function of x times the function of y? What do you think? Can it ever be written as a function of x times a function of y?
No,
I mean,
sir.
no. So X and Y cannot be independent. They are dependent. So the value, the distribution of X, okay, depends on the value of Y. So this is a concept which will be used, okay, in statistics, okay, and frequently. In fact, in all real world problems, okay, the basic assumption we make is just the example I was telling about picking a sample from, let's say, some company produces, let's say, some balls, okay, some electric balls. And the question is they want to calculate, or let's say it's a calculator, some company producing calculator. Now the company wants to know what is the average time for a calculator. Or let's say some company is producing some mobiles and there is the charge, mobile charge, okay, the battery is there. Some battery is there. Then the question is what is the life, mean life, expected life of a battery. One time you charge it fully. And the question is how long the charge will be there, whether it is 10 hours, 5 hours, 12 hours, some estimate the company has to give, okay, for the advertisement, so that people will buy the mobile, okay. So then how do they do it? What is the expected value? What is the mean value of the lifetime of a battery? So what they cannot take the entire population, that all the batteries they will produce, and they will test what is the lifespan of each of these batteries. They cannot do it. And they cannot do it in principle, because in the future, whatever they will be producing, that they cannot measure, the lifetime they cannot measure before it is produced, right? So the mechanism of the production could be same, but unless it is produced, they cannot do it. But they have to make a prediction that whatever it will be producing, that will also have an expected lifespan, let's say 5 hours or 6 hours or 7 hours or 10 hours, whatever it is. So in principle, it is a fact that you have to give a measure, you have to give a mean value for the lifespan of a battery. Then what you can possibly do is that you can pick a sample. Sample means, let's say you can pick 100 out of whatever they have produced. It could be 1,000, 10,000, 1 lakh, doesn't matter. They'll take a sample of it and they'll see the lifespan of this. Now, whenever they're picking the samples, this choice of this sample has to be independent of each other. Like if you pick one particular battery, that should not affect the choice of the other particular battery. Okay, so the lifespan of this, whatever distribution does it follow for a particular choice, let's say the first one, so the independent of the lifespan of the second one. So this independentness of two different random variables inherent whenever you will be doing some kind of practical study. Okay, in some cases also it will depend. Okay, that is not a part of the syllabus of this, but independentness is very, very important when we'll talk about statistics. The sample has to be independent. Okay, this is very important concept, that independent random or stochastically independent random variables. So whenever you are measuring some things, height, weight, anything, okay, corresponding to something, then this measurement, so that they are independent or not, that is the very, very important question. And from this concept will define something which is frequently used in the entire statistics and probability theory, which I did not define it previously because I was waiting for this to happen, like this concept of independence to follow, and then we'll define this, which is very, very important. And this is the assumption what you will do if you are in a company or doing some kind of data analysis or something. This assumption is always made. Okay, two random variables are called independent and identically distributed. In short notation, it is called IID or I.I.D. Independent and identically distributed if and only if, let me write, if and only if the random variables are independent and have the same distribution. Okay. In fact, this definition can be generalized to any n tuple. Here I just talk about two random variables. It can be for any number of random whole xn. And I'll call these are, let's say, all IID. This is a notation IID n01. It means each of these follows normal and they're all independent. Like whenever you are tossing a coin, when you talked about binomial, okay, when we are talking about binomial, let's say you made 10 tosses, okay, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Let's say 8 tosses. So this is Bernoulli. This is Bernoulli. This is Bernoulli. Everything is Bernoulli. And they are all independent. So this is actually a sequence of 10 IID Bernoulli. They have same distribution and they are all independent. So this is an example. Okay. So this will be used frequently, but yeah. So okay, let me give you an example of what is the use of this independentness. I mean, this will be now whatever will be defining some parameters corresponding to a pair of random variables, whatever the properties or some measurement, okay, whatever we'll be discussing, everywhere we'll consider a special case. What happens when these random variables are independent? And we'll see that our life will be simple or easy when the given random variables are independent. Okay, let me just give an example that where we can use this independentness. Okay, let me say that suppose let x and y be let this be independent random variables, independent random variables with identical, so they're IID basically, identical distributions. Let's say fx is equal to e to the power minus x when x is bigger than 0 and 0 otherwise. So that means fx means the probability of capital X equal to small x. This is equal to the power minus x when x is bigger than 0. Similarly, you can say probability of capital Y is equal to small y is f of y, which is e to the power minus y when y is positive, and otherwise it is 0. Then let's say the question is, what is the PDF of a new random variable w, which is let's say minimum of x, y. What is the meaning of minimum of x, y? Whatever the value of x and y, you have to take the median value of that. That is how this is defined. This new random variable is defined. So you have to find the PDF of this w. Okay. Now here we will see how we can use independentness of x and y. Okay. So if I want to PDF, I can do two things. I can first find the CDF and then I can take a derivative and can find this what is called the PDF, right? So let me say G small w is nothing but probability of capital W plus equal to some small w. Small w is a parameter. So this means this is 1 minus probability of capital W is bigger than small w. So this means 1 minus probability of capital W is nothing but mean of x and y. Okay, this is bigger than capital W. This not capital W, small w. Small w is something, some number. It could be 1, 2, 3, so, but it is arbitrary. So then this is 1 minus. Now probability of mean of xy bigger than w means both x and y they have to be bigger than w, right? So x is bigger than w and y is also bigger than w. Now, since x and y are independent, it doesn't matter what are the value of y it takes. The value of x does not depend on the value of y, and the value of y does not depend on the value of x. So essentially, I can write this means probability of x bigger than w follows from the definition times probability of y bigger than w, since x and y are linear are independent. Now I know what it is. I know what it is because the PDF are given to me. So this will be 1 minus w to infinity f of x dx. F of x means e to the power minus x dx times, this is w to infinity e to the power minus y dy, because that is what the PDF. So if I take that, 1 minus e to the power minus w whole square, which is 1 minus e to the power minus 2w. So then I can find, this is the CDF, then I can find the PDF, which is dw of capital G it is. So I can find this PDF. So whenever I have a pair of independent random variable, okay, whenever there is some kind of a situation, and then I can write this as a product. This is the use of this independentness, and this will be used throughout the remaining part of the syllabus. So we'll always have consider cases when we say they are independent. Okay. Okay, so till now we have introduced two concepts, actually one concept, which is the conditional PDF. And from there, we talked about what is independent, stochastically independent random variables. And then we said what is called the IID, when you have more than one random variables. And then we'll say those random variables are IID, or they are independent and identically distributed if they have the same distribution. And these random variables are pairwise independent. Okay, so now what we'll do is, so these are the very basic concepts regarding the PDF of pair of random variables. So one is a joint PDF, another one is marginal. Using those, we found a conditional PDF. Okay, and we came up with the idea of independent random variables. Now, what we did for the single random variable case, once we talked about PDF, then we introduced the notion of expectation. So that means we talked about some measures, some values, some parameters, some property to analyze the properties of the random variables. Okay, so here we'll do the same thing. So once we have a pair of random variables, now the question is, can we have some kind of measures, some kind of values associated to the pair of random variables, which can give me an idea about how these random variables, or pair of random variables, are distributed. Okay. So here is the most important concept, which is called covariance. Like we had introduced the concept of variance of a random variable, which measures how much spreaded that the PDF is. So here we'll talk about what is called the covariance. Okay. Now before that, we introduce the concept of what is called product moment. There, for the case of single random variable, we talked about moments. Here we'll introduce the idea of product moment. It's very simple. Product moment for a pair of random variables. Pair of random variables. This is the notion. Okay, so let me just go to the definition first. So here is the definition. What is the product moment? So let x and y. Okay, so let x and y be random variables. They could be either discrete or continuous. This with the joint PDF. Let's say f of small x small y. Then we define then the product moment of x and y is very simple. It is nothing but expected value of the product of x and y. So, like we talked about weight and height. Here, let's say for the case of Legos, it's the base or whatever. If it is like a square 2-dimensional Lego, then we can talk about both the sides, the length of both the sides. Then it is the product of those values, and this is what is called product moment. It is kind of product expected value of the product of the random variable. So you can consider that this is a new random variable W. This is a product of 2 random variables. So it is the same definition. That can anybody tell me? Anybody guess what is this? How it should be defined? Let's say this is W. Then how the expected value is defined for a random variable? What is the expectation of a random variable W? How you can define if W is a random variable?
Integration W f of W.
Yeah, yeah, when they are continuous, right? And if it is discrete, then sum over W f W. Same thing is here. W is xy, so here sum, where there are 2 parameters. W is x times y, and the PDF is f of xy. That's how it is defined. X is in the range x, y is in the range of y. When if x and y are discrete, y are discrete. And for the continuous case, it is minus infinity to infinity, minus infinity to infinity, x times y, f of xy, dx dy, if x and y are continuous. Okay, so that's it. So this is what is called product moment. Okay, now why did we define this concept? Because we need to talk about covariance. Okay, what is the meaning of covariance? When you said about how much it is varying, this PDF, okay, how much it is varying, x, that it measures, right? When you say the mean is something and variance is something, let's say mean the normal distribution, mean is 0. Okay, so this is 0, this is the mean. You can expect the expected value means the values around this is very high, and let's say this is sigma. This is how much it is spread, a sigma square. So same thing is here, but here I have 2 random variables x and y. So then if they are not independent, let's say they are dependent. Okay, we'll see what will happen to when they are independent. But when suppose it is dependent x and y. Now the question is, how does it depend? How the values of x depend on the values of y? To measure that, we are introducing the concept what is called covariance. So they are how both varying, co-varying. Okay, that's why the term covariance. How both are varying. That is the measure. So here we'll define now what is the concept of covariance. Okay. So for 2 random variables, we'll variables x and y, the covariance okay, we'll write as sigma xy. Let's say 2 variables, let's say x and y, so sigma xy, or I'll write this as covariance of x and y, is defined as follows. So how did we define the covariance of a random variable? Can anybody tell me? Can anyone remember? How did we define sigma x square or sigma square? What is the definition? Variance?
E of x square minus E of x whole square.
Yeah, so actually we defined this, from which we prove that this is nothing but E of x square minus E of x whole square. Okay. Same thing we'll do here. So it is x minus mu whole square. Instead of that, we'll write xy. This variance is nothing but expected value of x minus mu x times y minus mu y. Where mu x and mu y, they are the means corresponding to the individual random variable x and y. So how this product, what is the value of expected value of this product? So that's why here first I define what is the meaning of expected value of a product of random variables. Here you have new random variables, which is translation of x minus a constant, and the constant is mean. Here y minus a constant, the constant is the mean. So where mu x and mu y denote the mean corresponding to the marginal PDFs, the marginal random variables corresponding to x and y respectively. Now, if you just write what is mu x? Mu x is e of x. E of x means, according to the definition, minus mu to infinity. That's for the case of continuous, f of fxx dx. But we also know what is fxx in terms of the joint PDF. So this will be nothing but minus mu to infinity. That's x. What is fx? Fxx is integration again minus mu to infinity f of xy dy, and again dx. So basically what you can write it in terms of joint PDF, this is x f of xy, okay, there will be two integrations, dx dy. Okay, this is what is mu x. Similarly, we can write mu y in terms of joint PDF, which is minus infinity to infinity minus mu to infinity y f of xy dx dy. Okay, or dy dx, whatever you can write. So this is what it calls calls this thing covariance of x and y. Now, what is the meaning of covariance? What is said is covarying. Now, covarying means what? X is a random variable. It is taking some values, and the mean value is mu x. That means x will take, so it will take some positive values, some negative values. Okay, and in general, it will be close to x. But there can be some outliers. I mean, there can be some values which are far. Hello guys, can you hear me now?
Yes, sir.
Yes, sir.
Hello?
Yes,
Yes,
sir,
sir,
you
yes.
are audible.
Guys, can you hear me?
Yes, sir.
Yes, sir, you are audible, sir.
Can you hear me?
Yes, sir.
Hello. Okay.
Yes, sir.
Okay. So there was an internet guy on the internet. I lost the internet. Yeah. Okay. Oh, it is recording. Recording is not stopped. Yeah. Yeah. So what I was talking about here is, let's say these are the value of x. Okay, some value x are taking here. Okay, and some, let's say the mu x is suppose here. Then the values are close to, most of the values are close to mu x. Okay, it can come from this side or this side. Similarly, you have this mu y, let's say. Some values are close to this. Close to this. Okay, then what we are saying is, I mean, what does this covariance say? Basically, x is varying here and y is varying here. Now, what can happen is x is increasing. So the values, let's say they are increasing from here to here. Then whether x is increasing or not, that's the question. So whether if height is increasing from 3 feet to 7 feet, whether weight is also increasing or not, that's the question. That I want to find out. Another one is, let's say x is decreasing, like the weights I'm decreasing. And the question is whether heights are also decreasing as par with the weight or not. So that kind of a dependence, that both x and y are increasing. When x is increasing, y is also increasing. Or x is decreasing, y is also decreasing. And if this is the case that happens, then the value of covariance will be positive. Otherwise, it will be negative. What is the meaning of otherwise? Otherwise meaning x is increasing, then according to x, y is decreasing. So if this, so then the covariance will be positive. This will be positive. And covariance will be negative when x increasing but y decreasing, or x decreasing and y is increasing. This happens, then the value of covariance, okay, will be negative. Now the question is, what happens if they are zero? When covariance of x and y is zero? Can anybody tell me? This is showing when it is positive or negative, this is showing some kind of a dependence. That then the value of
When
x
they are
and y,
independent.
yeah, when they are independent, that covariance will be equal to zero. But we'll also see the converse need not be true. Means covariance zero does not mean that they are independent. But if it is independent, then that is zero. Okay, so this is a little bit complicated. Complicated in a sense that when it comes to real data and you compute, let's say, suppose you know that this marginal means like the mu x and the mu y, you know this, then possibly you can try to compute this, the covariance. Then the question will be, what is the meaning of covariance? Okay, so whether there is a kind of a dependency or not, and if it is zero, then you cannot say anything. Possibly they would be independent, but you cannot say anything. But if you know that this is positive, that means when x is increasing, y is also increasing. If it's negative, then both are like they have the opposite direction, meaning x is increasing, meaning y is decreasing. But there's the next question, another question. What about the magnitude? Suppose we have a pair of random variables and it is positive, covariance is positive, but covariance is 10. And you have one more instance of a pair of random variables where covariance is also positive, but if the value is 100. Same thing can happen when they are negative. For some pair of random variables x and y, let's say the covariance is minus 10, and for some pair it is minus 20. What can I say? Whether dependence is more, dependence is less. Can we say that? Can we make that kind of a conclusion? And the answer here is no, we cannot in general make that kind of a conclusion right now, because this is not normalized, this number. Once we define a normalized version of this, then we'll call it a correlation coefficient. And then we can say possibly that what is the value of this covariance or the correlation coefficient. And depending on that, how X and Y depend on each other. Okay. So this covariance is very, very important because it gives you an idea how do this random variable X and Y, they are depending on each other. Okay. Now, if I want to, so like the way we had this variance formula, we had a ready-made formula, E of X square minus E of X whole square for the variance of a single random variable. Now here we are also looking for, can we have similar kind of a ready-made formula in terms of product moment, in terms of product moment here, E of Xy, and individual moments, marginal moments. Okay, can there be a formula? And we'll prove a formula, ready-made formula for the covariance. So this is the result. In fact, we'll prove that covariance of X and Y is nothing but product moment minus the product of the marginal moments. So Ex times E of Y. Let us just prove this. So this is covariance of Xy. According to the definition, is expectation of X minus mu X times Y minus mu Y, which is expectation of, just multiply this with this one. So X times Y minus mu X Y minus mu Y X. Mu X and mu Y, they are just numbers, okay? They are just numbers. Plus mu X mu Y. And we know that exponential expectation is linear. So this is expectation of Xy minus expectation of mu X times Y minus expectation of mu Y times X plus expectation of mu X mu Y. So this will remain E of Xy. We got the first term here for what we are proving. We got this one, a remaining term. Now what is this? This is some scalar times Y. So what is the expected value in terms of Y? When we talked about expectation of some random variable, we talked about this, right? What is some 8 times X? What is that? When we have a single random variable and A is a scalar,
Ex.
yeah, 8 times a scalar will come out. So here this mu X will come out, but it is expectation of Y then minus, similarly mu Y will come out, and then it is expectation of X plus, what will be this one? This is a scalar. So scalar means the random variable is just all fixed constant values. So the mean will also be the fixed constant, mu X mu Y. But EY is nothing but mu X. EX is nothing but mu X. EY is mu Y. So this one will get cancelled. So basically it is EXY times minus mu X means E of X times E of Y. This is the formula. Now, as an immediate corollary of this is, if X is equal to Y, so what is happening when covariance of X, then this will be nothing but E of X square minus E of X whole square, right? So covariance of X with itself. So when X is varying, how X is varying itself? It is nothing but the variance of X. That means covariance is a generalized notion. So this is equal to this. So that means covariance of Xy is a generalized version of the variance. Variance is defined when we have a single random variable. Okay. And covariance when we have a pair of random variables. By the way, yeah, things to note is that first, the product moment need not exist always. The way we said expected value of this is need not exist always. We talked about Cauchy distribution, for example. So product moment need not exist means need not be finite always. I can give you example, but oh, moment. I mean, but let us use the product moment need not always exist. This is meaning they need not it need not be finite. Second, covariance as a variance, this is always positive. Okay, or bigger or equal to 0. But for covariance, it could be negative as well. Okay, second is covariance of xy would be negative. Okay, so let us see an example. This is the problem. Suppose we have a PDF whose joint density is given as x plus y. When 0 is less than 1, less than x less than 1, y is also that, and 0 otherwise. And then let us find out, question is, find out the covariance of xy. So how do you do it? Covariance, we know that it is product moment minus the product of the expectation. So so first let us find out what fx is. If I know fx, then I can find out what is the expected value. Okay, the expectation of the random variable. So this is from 0 to 1, x plus y dy. Okay, which will be something. Okay, let me calculate it. This is 0 to 1 xy plus y square by 2 from y is equal to 0 to 1. So this will be x plus half. Then what is ex? 0 to 1 x of x dx. So which is 0 to 1 x into x plus half dx. So x square minus plus x by 2. So it is x cubed by 3 plus x square by 4, 0 to 1, which is 1 by 3, right? Plus 1 by 4, 7 by 12. So you already know what is the x. Now, since this is x plus y, if I want to find out f of y, the PDF, the marginal PDF of y, I'll get the same integration. Here just y will be replaced by dx. Same calculation I have to repeat. So I already know. Then similarly, same value will be there. Similarly, e of y will be 7 by 12. So I know expected value of x, expected value of y. Then what is the product moment that I have to find out? So e of xy I have to find out. The formula is, because it is non-zero when it's from 0 to 1, xy times f of xy dx dy. So this is 0 to 1, 0 to 1, xy, fxy is x plus y, right? Yeah, x plus y times x plus y dx dy, which is 0 to 1, 0 to 1, x square y plus xy square dx dy. So if I first take the dx, then x square means x cubed by 3 times y plus x square y square by 2. Okay, and dy, right? And this is from 0 to 1. So this is 0 to 1. X is varying from 1 to 0 to 1. So 1 means it is y by 3 plus y square by 2 dy. So then this is 0 to 1. Y means y square by 2 is 6. Okay. Y square by 6 plus y cube by 3. So 6, 0 to 1. So 1 by 6 plus 1 by 6, which is 2 by 6, right? Yeah, so 2 by 6, which is 1 by 3. Then what is covariance? covariance of xy is 1 by 3 minus ex times ey, which is minus 7 by 12. So 7 by 12 times 7 by 12, which is 1 by 3 minus 49 by 144, which is 144. So then we have 48 minus 49, which is minus 1 by 144. So this value is negative here. The covariance, value of covariance could be negative. Negative meaning when x is increasing, y is decreasing. Then you can have a generalized formula for covariance. This is also again a result like the way we talked about for the formula for covariance of or the expectation of ax plus b. We had a formula. Can anybody tell me what was that formula? And not covariance, but the variance. Variance of x plus b. Can anybody tell me when x is a random variable?
A square times variance of x.
Yeah. So similarly, we'll try to find some formula for covariance of, let's say, x plus b, and let's say some cy plus d. But I'll leave it as an exercise, and this will be a times c covariance of xy. What is the guess that this will be correct? See, if I replace x by y, this should match with this formula. So x and y means this will give me the variance, and this is a square, right? So that's why a times c. Okay, so then let us solve some problem. Let's say, I mean, problem means using this formula, you can just find some problem. Suppose let's say this is given mu x equal to something is given 3. Suppose this is also mu y. Okay, and let's say e of xy is also given something, let's say 4. Then you are asked to calculate what is the covariance of 2x plus 10 and minus 5 by 2y plus 3. Okay, so you can use the formula and find out its value. A typical kind of problems. And then another result I will not prove, but let's say there are 3 random variables, x, y, and z, and I want to compute, let's say, covariance of x plus y and z. So this is again covariance of 2 random variables, but one random variable is a sum of 2 random variables. So this can be proved like covariance of xz, x comma z, or x comma z plus covariance of y comma z. And also instead of this x plus y, if the second component is a sum, so therefore this y plus z, then this is covariance of xy plus covariance of xz. This also you can prove using a similar formula. Okay. Now, so this is for any general pair of random variables x and y. But what happens if they're independent? Okay. First formula. So here, what happens? What happens to all these formulas? To all our formulas when xy are stochastically independent. First, let us talk about the product moment formula. First result. The product moment will be actually product of the expectation. And hence the covariance will be equal to 0. Why? Okay, this if x, y are independent. Product moment is the product of the expectation. So what is the proof? See, if they are independent, then this product, this joint distribution, joint PDF, can be written as f of x, the product of the corresponding individual or the marginal this thing. Then what happens? E of xy. E of xy is according to the formula, it is infinity minus infinity xy times f of xy. And for the discrete, it will be summation. Similarly, can be proved, but let me just prove it for the continuous. So, but fxy is nothing but the product. So I can write infinity minus infinity xy fxx times fyy dx dy. And now I can make a product of everything because it is x times this is independent of y and this is independent of x. This minus infinity x fx x dx times minus infinity y fyy dy. And this is nothing but our ex. And this is nothing but our ey. So ex, e of x times y, the product one is the product of the expectation. If that is the case, then as a corollary, you can say the covariance of xy will be 0 if x and y are independent. And the proof follows from the fact that covariance of xy is e of xy, x times y, the product one minus ex times ey. But we just have proved that e of xy is nothing but ex times ey. So this will be ex times ey minus ex times ey. So this is equal to 0. But the question I said is that xy, if xy are independent, then the covariance is 0. But the converse need not be true. Meaning, but this is not. But the converse need not be true. Meaning, that is if covariance of xy is equal to 0, that does not necessarily mean that xy are independent. Meaning the product, the joint density is a product of the marginal densities, independent. That need not be the case. Okay, so let me give you an example. I mean, say this is the case in mathematics. When you say that some statement is false, need not be true, that means you have to find one example of two random variables for which this is not true. For every random variable, you don't have to prove, because every random variable may be true as well. Because if they're independent, the covariance is always 0. But covariance 0 need not mean that they are independent, meaning you have to find two random variable x and y for which covariance is 0, but the joint density is not the product of the marginal densities. And the example, I'm just writing it here, you can prove it. So you can find the, so I'm just giving you the joint density. This is, let's say, 1/4 if xy are of this type. Let's say either 0, 1, 0 means x is 0, y is equal to 1, or 0 minus 1, 1, 0, minus 1, 0. They are the 4 values, and 0 otherwise. So that means what is the graph of this? So basically this is x, this is minus x basically, and this is y, and this is minus y. So if it is 0, and so x is 0 and y, so here I cannot probably draw it. Okay, minus 1, minus 1, 0. This is minus 1, 0. This is 1, 0, right? This is minus 1, 0. Yeah, and 0, minus 1. Let's say here. So you have these values, these 4 points. The probability values. These heights are all 1/4. Okay, this is f of xy. So these heights are 1/4, and everywhere else it is 0. So this is the PDF which is given to you. At 4 values, it is 1/4. And then find out what is the covariance and show that it is equal to 0, but f of xy is not equal to f of x times f of y for all xy. This we have to find out. Okay, then you can claim that this is the converse need not be true. Okay, so we are running out of time. This is where we'll end here today, and all the best for your exam tomorrow. Okay, and I have uploaded what is called the exam protocol